Hello, everybody. This is Jason from Lunatechs. Quick intro about us. We're a global tech community of tech enthusiasts. We do both online and offline events. So if our website is lunatechs.social, if you ever get a chance, please drop on by. And I want to introduce to you our first online course. Consists of 12 sessions. It is a course called Understanding AI for Executives. The objective of this course is to not to ask you to know the ins and outs of AI, but to help you understand what AI is, to be able to ask the right questions, and to be able to implement AI successfully within your company and your organization. The entire course is 12 sessions and it comes in two parts. Part one is focusing on the foundational knowledge and strategic architecture of what is the new AI landscape. And then part two is focused on case studies and projects. So that will help you understand how various different types of AI projects are landing within different industries and what you can learn from their best practices and success. So, beginning with session one, how is this new AI different? I'm going to give you a walkthrough of AI development as it was historically so that you can understand why this time we think this AI is different. So, in the early 70s, even 80s, the first generation of AI was something called predictive AI, which was machine learning. And these were essentially pure math applied to real world problems. And they had very fantastic predictive powers. And I'll go into examples of what were the things that they were trying to predict. That was the first generation of AI. And as more and more unstructured data became available, there came this next generation of AI called natural language processing, which dealt less with numbers and more with words and how humans were using words. So popular applications are things like spam filters or help desk routing. And then now what we have starting roughly in the 2017s is what we call the modern era of generative AI. And this is the AI that you know today, which that the AI that is making photos, the AI that is writing essays and doing code. And uh, I will tell you why they're different, how can you think about them differently, and mm, why we think they fundamentally change a lot of things. So now we're in the first era of AI, and this era where AI was pure math. And here AI was mostly doing was statistical detection. It looked at historical customer and sales records. Those sales records, those data had to be cleaned. They had to be loaded into a database or Excel sheet or some kind of a uh, data processing engine. It crunched all the numbers to see what the result was. And then from that, it could give you whether it be probability or some kind of assignment of what it thinks the outcome was. The nice part about this is that it was era AI in this era was fully explainable in that all it was giving you was a linear regression of what they saw from the data. And when you presented it with new data, it would tell you, hey, this data looks like that. So for example, things like customer churn, right? If somebody who opened the application or visited your website 3 times in a row, then they are less likely to be someone who churned. Or for things like traditional credit scoring, where they look at your, income, zip code, education level, all these various factors, and then it calculates a credit score for you, or something like actuarial science, right? Where it's looking at a bunch of people, looking at their health statistics, and estimating what a potential health payout would be. So these are all traditional machine learning, but back then it was basically called AI. And if you remember from college, this all runs on statistical regression. And what that meant was you had to get a lot of historical data, and you had to make sure that the data was clean and that the data was not biased in any way. And you ran a regression to figure out where this line in the middle was. And that will give you a good sense of if somebody came with a bunch of new numbers. So in this particular case, someone get, your input was, beta 0, beta 1. Someone came out with a new, says, hey, I'm a new person. Here's my beta 0 and beta 1. You will be able to estimate for them where they are on this line. In this case, you're never perfectly accurate, but you were doing better than pure guessing. And this was uh, state of the art AI back then. So this is the example of how something like this might have worked. You start with a baseline score. In this case, the baseline score can be positive, negative, anything. And then you throw in a bunch of factors that you could observe and measure. So for example, uh, this is a $2,400 electronics order at 11:52 p.m. So this order size is, 8 times bigger than this customer's average order size in the last 7 days. So that all is often correlated with a high risk of it being a fraud. The shipping address matches the billing address. In this case, no, then that's another positive signal that tells you that this is a potentially a fraudulent transaction. And then is it happening on a device that you've seen before? So are you logging in from um, your own computer or logging in from a new computer, right? And then so all these are factors that when somebody is making an order, you know about them right away. And then based on all this information, you say you assign some kind of odd fraud, some kind of percentage that this is a fraud. In this case, this model will say, hey, this looks like 83% chance that is a fraudulent transaction. So I'm going to hold this account for review. And that's essentially how most uh, linear regression models, machine learning models worked, whether it is for pricing, whether it is for uh, recommendations. A lot of it was based on all these factors. And based on these factors, it will give you a number for what it thinks this outcome might be. And based on that number, the business takes some action. And how this was done was you had to have a huge database with lots and lots of different inputs to even get started. And this is really what sets apart the companies who started doing this day one versus the companies that later on decided, oh, I'm gonna add this later. So when Google and Facebook were first starting, they already knew about this technique. And day one, they were saying, I'm gonna capture all the data because they know that capturing data later is much more expensive. So you start with this huge database, and then you had to go through a very expensive data cleaning process. Again, for the likes of Google and Meta, because they knew that when they were starting, they had to do this. They made sure that their data was cleaned as much as possible at the point of data creation, so then they don't have to spend money cleaning it up afterwards. Whereas if you were somebody who were coming into this halfway through, you basically had to spend a lot of money doing data cleaning. And that was really a part of this data moat competitive edge in the early internet era. Once you had clean data, you will run your model, and this model would basically be tailored to your specific company based on your own data and is only useful to you uh, at any given time. Once you have this data, you would then put it into your application. So for example, whether it be risk scoring or whether it be advertising recommendations, and then you observe the data, you observe what the predicted result is with your actual result, and then you modify the data or you modify the model so that it performs better over time. And the most expensive part of this was, assuming you already had the historical data, was the basically the data engineering, cleaning the data and then making sure that the data didn't have any statistical biases. So meaning sometimes you're creating data and then, for example, if somehow somewhere in the code it was adding an extra decimal everywhere for your data, because this data is not part of your actual production, right? So somebody was making a purchase is $12, but then during the data copying process, if it all became 120, small bugs like that, it would basically throw off the entire prediction machine. So data engineering and data cleanup was the most extensive part. And often for really large projects, most of the billing went into this. And basically, after you had the model and you were sure that the model was accurate and working, the actual cost of running the model was incredibly low because these aren't really high powerful models. They can be calculated on any commodity servers and didn't take too much work to run these models. But the most of the costs was constantly maintenance and constantly cleaning up models or data. So this is one of the most famous examples of linear progression from the when things were first applied. The story goes that Target, they realized that if you could get somebody who was a mother to with a new baby to shop at Target, they would spend on the order of magnitude several times more compared to somebody who wasn't a mother with a new baby. So their statistician figured out that, hey, look, if somebody bought these 24 specific products, the chance of them being a uh, mother with a new baby coming was extremely high. And these are things like, unscented lotion, zinc, calcium supplements, cotton balls. Kind of makes sense if you put it on a list, but then if you didn't run the data to get you this list, it's kind of hard to pull out of the box. And basically what they did was they once they calculated these products, they deployed it and they were looking at people who were buying these things, and they would send promotional coupons to all these households who hit these scores. And what happened was, in one family's case, was the the daughter in the family was pregnant and she was buying these things at Target, but then she hasn't told her parents yet. So then the parents got promotional coupons for a baby that they didn't know were coming, and this caused this big, um, basically this big scene in the house that they're like, how did you know? How did Target know that somebody was pregnant even before their parents? So that's the most famous story from machine learning back in the early 2000s. And then so those were the early models, and basically they saw very widespread worldwide adoption, especially in things like finance and risk. Basically, all of algo trading is this machine learning model. Fraud score and credit scoring again uses the exact same thing. For internet, in for Google, for Netflix, recommendations, discovery. If you like this, you like that. And for things like for things like uh, ad targeting, right? If you search for A, the chance of you also buying B is very high. There's all sorts of applications in the internet, and basically that's what made these internet companies incredibly profitable compared to the early days. And then also in things like supply chain management, dynamic pricing, demand forecasting, if weather is hot in a certain area by 1 more degrees, you could predict that electricity consumption will go up. You could predict that soft drink consumption will go up. So there's all these predictions that companies used to make based on the data they had. to manage their businesses. And that was all of the first era of machine learning and AI. Uh, and then from that, we got into this world where there were now a lot of unstructured data. And what is structured data versus unstructured data? Everything we had talked about up to now was essentially structured data. On the left side, you see that there's columns and rows. That's what structured data is. There's a customer ID. The customer bought unscented lotion, and that's SKU 4471. They bought two on this date, and then they bought zinc, and then they bought something else, right? So this is structured data. It lives in the table, and you can process it using traditional data processing techniques. And what is the unstructured data? Unstructured data is basically the post-internet data. This is people who are saying, hey, what's up? Or people are saying, hey, this is not bad for the price, but shipping was a nightmare. These are all these data that is essentially words, and they are not um, at all organized in any way. But because websites and social networks were gaining so much popularity, people had to invent new models and new ways of processing these data in order to uh, derive new learnings from these data. Um, and one of the benefits of this unstructured data compared to the old way of doing it was if in the old days, say you want to do a project, but you didn't have the metrics set up, you will have to define the metrics. You would have to build all the data pipelines and to do all this investment, wait to collect a bunch of data, and then you have your initial results. So the ROI for those kind of projects were very long, which again made companies that had the foresight to deploy the right data process type pipelines super give them a huge competitive advantage. So Google compared to Yahoo or Facebook, they knew that they wanted to do structured data, and they had the setup ready to go, so they could avoid this whole waiting time period. For language AI, it's actually not as complicated, meaning most companies probably already have existing communication archives, right? If the customer was emailing you about something, or you already had your Twitter, and people were already talking to you on Twitter, you were able to skip this entire process associated with creating and then maintaining these structured data because the data inherently is unstructured and people are already talking about you on the internet. You could essentially day one to say, okay, I'm going to run my data for all the historical results and then see what happens. So that was also a big difference in when you were doing an AI project. If you were doing it on natural language data, you have much faster ROI. So this is something that was uh, didn't foresee it. And then when people were doing these projects, something that they found out about just the timeline of the project and the complexity of the project. So the second era of AI was mainly, for lack of a better word, like counting words. You were trying to see things like, okay, like is this a spam email? So you count the number of suspicious words that were in the email. You're trying to see like were customers happy or unhappy about you. You had to look at data and trying to see like if this is a positive sentiment, negative sentiment, or neutral sentiment. And a lot of this was very manual. So word counting, very manual. You had dictionaries of uh, when someone says this word, it doesn't mean that it's talking about my brand. Or if somebody says this, that's specific jargon in our industry, and we need to process it differently. So uh, that was basically this was the processing that we used to have, but then now it was more industry specific and more company specific. And so this is an example of how one way of doing natural language processing using this, what we call the inverse document frequency method. So imagine you got a email, right, or you got a support ticket, and in this support ticket, you have 100 or maybe 200 words. What you're looking for was the least frequent word in this document to see, and chance of that word in your entire company appearing means that this word is probably the most important. So in this very case, right, we had a refund request. I was double charged. I got for 450 on a subscription renewal. Words like the or on happens incredibly often. So, and they're, more or less essentially meaningless. Things like account for support tickets, people are going to be saying that word 4 or 5 times, and it just doesn't mean that much. Subscription, that's a little bit more rare because now okay, this person is talking about their subscription, something they paid for, and then words like double charge, incredibly rare. So then that becomes the most important thing. So by using this inverse document frequency method, they were able to quickly identify what is the main point of this support ticket and then route it to the right people. And as you can see, this is there's no black box. This is just purely counting words and some companies might have some words that are more important than others. So maybe they'll change the weight, but basically no black box. They know exactly what the outcome is and how to route it. And that's essentially how these models were built. You had all the text. The text it can be from your own company, or it can be internet text like on Twitter, or go to any forum where they will talk about your product or company. You would do the text cleanup. So things uh, like incomplete sentences are probably one with something you want to kind of like parentheses or all these words that you think is not important. You would clean up all those texts, and then once you have do that, you had this dictionary, right? And dictionary, for example, words like awful, you think that's a negative thing, so you tag it. Or I had a great experience or really enjoyed. Those are positive words. So you had this dictionary where you were associating each words with the sentiment that you wanted, and then you ran that through the model and try to see, okay, within the sentence, how many sentiments were positive, how many were negative, what were they associated with, and then you could come up with a combined score. And similar to the first model, in our current case, most of the money for a NLP projects were people were spent on people doing data tagging. And this is incredibly important because essentially, if you had all these words and you counted them right, but then you didn't tag them correctly, uh, there's a high likelihood that uh, the result that you got was wrong. And a part of it is like, the same word misspelled 3 or 4 times or common misspellings. You have to make sure that they were all tagged consistently and that you weren't missing anything. Or you might have a case where your brand or a word is misspelled differently on by region. So then you have to make sure that that's also accounted for because otherwise you are missing all these data. So most of the time for a NLP project, most of your spending was on these data tagging. And then once you have this data tagging, you might, bring in someone who's a computational expert or linguistics, somebody to basically review your dictionary and the lexicon you have set up to make sure it was good and that you're really capturing all the nuances of the language. And then you had, 1 or 2 engineers who basically built a model for something specific, like Twitter sentiment. That could be one model, and then you could have a different model that could be like whether or not your support ticket, this person was angry or not, or it could be that you have a third one. It could be for LinkedIn and whether or not people on LinkedIn were talking about you positively or negatively from a recruiting perspective. So that's the kind of the second generation natural language processing models. And essentially, they were, from a company perspective, uh, was the same. Most of your money was spending on people trying to clean up all these data, making sure these data work for you, and then deploying the model and running it on essentially very cheap hardware, right? You didn't have to need super powerful computers back then to do any of these models. Uh, what are some example of that? Spam filter. It is the one of the earliest products where there was huge amounts of data. Essentially, Google saw they had Gmail, and you can basically you knew everybody's. You could see the terms in those emails, and you could pretty easily see like when someone keep on telling like when the word Nigerian prince came up that and most people were saying, oh, this is a spam email because there aren't that many Nigerian princes sending out emails that are identifying them as Nigerian princes. Those words ranked extremely high to be um, to be spam, and you could instantaneously recognize that, right? So under 5 milliseconds, you scan the entire email and you find the one or two word that says Nigerian prince, and this person in their email, in their document, in their email corpus does not talk about Nigerian princes. This is most likely a spam email. And because of that, because of those companies, you're able to filter out 99% of mail from that. So in this case, same thing. This is for spam. You could imagine for customer support or for sales inquiries, same thing. If you had one or two words that you knew were incredibly rare, but they were very high power words, you could just very quickly zero in on them, find out from the volume of hundreds and thousands of emails, which one was the most important email, and then have your salespeople go after that directly. So that's the kind of the second generation natural language processing AI from like the second generation from like the early 2000s until 2015, 20. And there's still more work being done on natural language processing uh, in terms of the real world business adoption. Info desk and help desk, the number one most widely adopted case of NLP spam detection, whether or not it's for you or for a business. You basically filter out these people who are just uh, sending out emails. And this is also for the feature like priority inbox. It knows who you're talking to, and it knows the if it's something if it's a project name that's come up 2 times before and then now it's a third time it's appearing, probably a high priority email. Same thing for brand monitoring, just people monitoring if people are saying nice or positive or negative things about your brand. Where are they doing it? What platforms are they doing it? Is does that mean something is happening that you need to go and triage? And then also for in the back office, you can also use natural language processing to really very quickly sort out documents. So for example, if you had hundreds and thousands of invoices and you're trying to find invoice for particular people, chances are the company name is a incredibly infrequent occurrence on a particular invoice. So if you say, okay, well, just use the technique to find me all the invoices associated with this company or to see the health of this company, you can very quickly zero in on that data set without having to open up every single document and scan through everything trying to find out what that is. So uh, widely adopted, especially as internet and social media became more and more widely adopted for business. People are using NLPs more and more just so that they can better manage their business and the volume of inbound support tickets, Q&A that came in. And then so those were the two previous generations of AI. And then now we're making this particular big shift into what we call generative AI. And in the two examples that I gave, the output was mainly static. So for example, in credit scoring, it just gives you a number, right? The number could be 12, the number could be 200, but it didn't really give you any words other than the number. Same thing in the NLP use case. It can give you things like, oh, this is a positive sentiment, this is a negative sentiment, but it was basically very, very restricted in what it gave you. So the output was mainly static. And in this case, in with this new era of AI, what we're seeing called uh, generative AI, the output is actually extremely wide ranged. And so this is the AI that can, sing, it can give you writing any style you want, and it can give you uh, movies if you want, right? So that's the first big change compared to AI before, this idea of it being generative and generative across a wide range of things. The other big change between the traditional AI and the new AI is in the traditional AI, you basically had one model to do one job, meaning you had one model whose job was to do risk scoring, and then you had another model whose job was to do fraud detection, and you had a third model whose job was to do sentiment analysis. One model can only do one thing and do that thing well. And here, with these new like modern generative AI models, large language models, that goes away. You can have a single large model do multiple jobs. And the third biggest change compared to before was in the traditional paradigm, you had to do a lot of the data preparation yourself, and it was all manually done. You had to invest heavily in data engineering, in data science, and all these things. Whereas in these new generative models, the model basically comes batteries included, right? You open the model day one, and the model knows statistics, the model knows how to write code, and the model knows history, right? So those are some of the biggest changes when we go from these traditional static output models into what we call these new generative models. So what is this generation model? And you hear this word foundational model a lot. And foundational model is really this super brain that people have been training. And what it does is, unlike the models we used to talk about, where you have to give it things very specific things like the users who their purchase history or the Twitter history or LinkedIn history. In this very case, for a foundational model, you just throw as much as you can into it, meaning whether it's like, documents, code, history, foreign language, movies, anything you want, just throw it all into this model. And this model, through the way it is structured, can essentially learn anything. And once it learns anything, it now becomes this super brain that essentially can help you write legal contracts. It can help you it can understand finance. It can help you write code. It can do anything for you. So when people say someone's building a foundational model, that's really what it means. It's this super model that can do anything. And so the super model that can do anything, it it had to get there in some way, right? And this is in what we call the Moore's law of large language models. So Moore's law, if you don't know, was describing that semiconductors, they shrink in size, or they double in size basically once every couple of years. And then we're seeing the exact same scaling that's happening in large language models. So in this chart, it is a log based chart. So meaning in 2018, the largest models back then were around 94 million parameters. So parameters is, you can think of it as a proxy for the number of things that it is tracking and processing. And by 2023 with ChatGPT 4, we were already hitting over 1 trillion in parameters. So this is essentially the learning that happened in roughly 5 years. It basically quadrupled or multiple x its learnings. And that's what really enabled modern day where we have these uh, really powerful and really sophisticated models. But then at the same time, that's also what makes these models now you couldn't run it in your own computer anymore. You had to have these like huge data centers, and that really fundamentally changes how you deploy your models. And we'll talk about that later. So yeah, so the difference now is the barrier to entry for your predictive models or for language processing models. You had to go hire a bunch of teams, and then you had to have enough data for you to jumpstart your process. If you're like a brand new company, and you had no data whatsoever, that was a huge barrier to entry for you to do any kind of AI project on your own. And now with these new models, because they are now over a trillion parameters and they've been learning from everything on the internet, there's very little data moat left. You could instantaneously take a off-the-shelf state-of-the-art model and it will translate from English to Chinese, English to French, English to Spanish, all of your product documentation for you. And then it can also go and read all the reviews and tell you what your customers think of your product, what they like about it, what do they hate about it. And you can just do it day one, right? So the barriers to entry for applying AI to your company has now dropped to nothing. At the same time, the cost is also very changed. Whereas before you had to uh, maintain a huge department of people, data science, you had to buy servers to basically store all this data, process all this data. Now, what most people are spending their monies on are basically tokens. And these tokens are essentially they're kind of like a unit of information that needs to be processed. And the more you use them, the more you have to pay for them. So asking somebody to write you a paper that's like 12 pages, and then now asking someone to write you a paper that is now 24 pages, your cost just goes up double. And this is really different from before when you're trying to see like, okay, well, how what do people think of my company, and you saying, okay, well, I want to read from 12 users versus I want to read from 24 users, the cost didn't really change that much because the model was uh, fixed and it could didn't really cost any tokens to do that sentiment analysis. Uh, in terms of like the source where you got it, most models back then was in-house. So you couldn't like if you were from Google and even if you had access to a Facebook model, it probably wouldn't work for you because all the data was trained and on how that company specifically operated. And now, that kind of goes away, right? You can basically take any company to use any model and it will work for you. So the ability to kind of deploy these models and source these models have also fundamentally changed. In terms of capabilities, now our models they're universal generalists. They're one model that does everything. It's one model that serves the entire company. Whereas before, whether it's traditional machine learning or NLP, they were bespoke models that only did one thing and one thing well. And if you want the model to do something else, you basically have to retrain a whole new model. And then lastly, in terms of how models are adopted and used within the company, back at Google, basically there were these people who knew when the model spoke, they know what it meant because they were the people who built the model. And then if you got someone else come in, they would take them a long time to learn how the model functions. And once they learn that, then they can start working with the model. But basically, from everybody else outside the model, team, they basically didn't know uh, enough information to be able to use the model properly. And now these days with large language models, because it is a language model, you essentially can use it. You can speak to it in English, you can speak to it in Chinese, you can speak to it in Spanish. Anybody is able to use the language model, and that's really what the combination of this is really what fundamentally makes large language models and this generation of modern generative AI so different and so revolutionary compared to previous generation of AI and models that were running is the fact that there's no data moat. It can be turned on at any given time. Anybody can use it. You don't have to be a special, you don't have to be a trained specialist to use it. So the only limitation is basically like how quickly can you do it? And essentially you're seeing this uh, huge rush from people to trying to adopt AI everywhere within your company for good and bad. But this is kind of some of the drivers of that. Um, so in terms of model deployment, we're in Hong Kong. You could run your model within your own company and self-host it. There, and then or you can use a public vendor like Google, Anthropic, Alibaba. They'll have these models. And here the change is really a you if you want to do AI project these days, it goes from a deployment question, which is, are you happy or are you okay sending your data externally to some third-party model company? Because now the models are so big and the models are so complex, there's essentially no way for you to run them within your own company. And this brings in things like legal challenges. This brings things like, um, can you work with like do you have to have now two different vendors in case you don't want to have a single vendor, but then the models are different. So the complexity of deployment is now more more complex, but at the same time, the cost actually has gone down because you don't need to hire this big army of data scientists or data cleaning people to even get started, right? You could just open an API, charge $20, and then be off and running. So again, fundamentally changes the characteristics of these AI projects and what you can do with them. So just to illustrate that, we have an operating economics of a model, right? So now instead of before, you still had domain experts and you had data scientists. Now all you really need are these like domain experts. And these people are the people who when they look at a model and they look at the model output, they can tell you, oh, this looks like high quality information, or this is looks like low quality information. So if you're in customer service and the model tells the customer XYZ, you basically need somebody who is a domain expert to be able to say, hey, that's not a good answer. Don't say things like that. And most of the time you're already have these people in the company, right? These are just basically your mid-level managers, and they do things like quality control. They teach people how to do things, and before they were teaching humans, now basically they are teaching AIs. So these are the domain experts. The compute usage and the tokens part, this part is new and this part is variable. And by that, I mean, in terms of traditional IT spend, we're very used to IT spend being flat or decreasing year over year. And with generative AI, the nature of spending will not be like that anymore. It will most of the time increase, and most of the time increase exponentially the deeper and the more you use AI within your businesses. And that's going to be a huge trade-off that when we are doing an AI project, we need to think about how to manage that. So I'll give you an example. Uh, why that is essentially if I'm using AI, I'm using AI to write something, and then somebody else uses AI and somebody else is using AI to write something, that's 2x the cost. And then now you're going to be like, okay, well, I'm going to have my AI talk to their AI, and this is uh, something we'll talk about in the future. Agentic AI, suddenly now the AI is asking five different people for information that it didn't used to ask before, and that's going to consume way more tokens compared to where it was just either machine learning working on one particular field or a single person using AI. And now, as more and more AI start asking more, especially cross-departmental questions and looking up data across different places, the token cost really goes up. And then lastly, in terms of the integration, it is pretty easy these days to do a AI enterprise integration, especially a lot of times these integrations themselves are built by AI these days. So the really AI is bootstrapping itself into enterprise adoption, but the hidden danger here is really the token costs will go up uh, potentially exponentially the deeper that you use AI within your products. Hey, but the good news is you're not hiring an army of AI researchers in-house. You're not hiring an army of data scientists. You essentially can take something off the shelf and then use it across your entire company. So those are really the big trade-offs with this era of modern generative AI. Very famous examples of how AI can change the way that businesses work for Amazon has lots and lots of legacy products that essentially never gets prioritized and never gets worked on, right? So you have something that's super old and just is running, it costs money, but then updating it will cost you more time and more money. And most times people say, okay, well, rather than saving money, I want to build things that's going to make me more money. So old programs are basically never prioritized. And then uh, somebody within Amazon basically figured out, hey, look, you know what? I'm going to rewrite all of our software, all of our old software to the new standard, and it's going to save a bunch of money. And I'm going to have the AI do it. And they just did it. And then essentially, because AI just never rests, it can just continue to write continuously code. It basically took rewrote every single code that was old and then moved to the new one. And it cost them essentially 4,500 developer years because there was so much code. But because AI never sleeps, it can just do it nonstop 24/7, and it ends up saving them $260 million in recurring maintenance costs. And that's a really powerful use case of there with generative AI is now you can do things that before for cost reasons or for resource reasons you couldn't quite possibly do, but now you can with generative AI, and that's really going to transform or change how a lot of people think about how they do business. Because really now a lot of the costs you're going to have a different cost profile with a lot of these different projects, and you can need to evaluate the ROI of these projects differently. So that's an example of kind of how modern generative AI is changing how we think about what kind of projects within the company you should be adopting. So real enterprise adoption, unsurprisingly, number one is software engineering. The all these models, they were made by software engineers, so they know software engineers best, and you can use it for software engineering tasks. You can use it in Amazon's case to maintain old code, and I know basically every Silicon Valley company is doing this, and that's why they're able to uh, keep their headcount flat or even letting go of large departments because you don't need that many people to maintain code. If you can either use AI to maintain the code or you can just rewrite the code. In legal and finance, where there's lots and lots of documentation, and LLMs are really good at reviewing through all this, doing comparison between two different documents, and they give you uh, scan through the volumes of documents that a team will never be able to do using billable hours. So LLMs are really good for that, and you're seeing that in a lot of basically AI-assisted research cases. And then the third part about AI that we're seeing a lot of it is LMs. They're really good at doing multi-turn conversations. So you ask, hey, how are you? The AI will say, hey, I'm doing good. You can just keep on talking to AI about very different things. And that's really useful for things like customer um, service or customer support, where the AI can remember what it's trying to do. And the AI can at least talk to the customer about a few times, figure out what they want, and then figure out where to route this customer, or just make notes as like, hey, I talked to this customer, they're angry about XYZ, write it down, and then somebody can follow up, like a real person can follow up and talk to them about it. So real world AI adoption. And then, yeah, so that's kind of the summary of our first session. Primarily, we wanted to show that, hey, to show you kind of how AI has evolved over the years. In the first era, it was mainly what we call predictive AI, machine learning, where it had a fixed data that it could learn from. And from that fixed data, it could predict something like a risk score, or it could predict something like what the uh, price of a particular stock might be based on historical data, and it all does it with linear regression. The second generation, as web became more and more popular and their social media came up, people were talking more and more about things. This had a You had to use different data to process this data because it wasn't neatly recorded in a table. You might not have as much historical data. Um, but the good news was you didn't have to spend you didn't have to prepare these data, you didn't have to collect this. These data were all there, so you could start working on them right away, and you could start getting insights right away from this. And this led to more things like spam filters, help desks, and being able to quickly figure out, hey, what is this person contacting you about? And but having said all that, the first two era of AI was really specific, meaning you have one model that will do one thing and one thing only. And then if you want to do it to do something else, you got to do a new model. You had to hire all these armies of people to run, to fine tune, and to maintain these models. So unless you were a really big company, if you're a really small company, A, you probably didn't have enough data, and B, you probably didn't have enough budget to do an actual AI project. And all of that basically changed in this modern era of generative AI, where you could be anybody. You didn't need any sort of customer information. You could just pay $20 or $30 to a AI company, and you would be working with the latest state-of-the-art model. And this new model is essentially, it's batteries included, and it does everything under the sun, and it does it in all languages, right? So this is really great for smaller companies, but at the same time, the the economics of it change. The economics of how to consume this model also changed in that before you were basically, paying per your most of your spending was capex upfront, and then as your business scaled, the expenses stayed flat or it went down because you're able to get leverage out of your investment. But in the new modern generative AI, it doesn't work like that. The more customers that you serve using these LLMs, you're paying more for each customer, and the more you are asking the LLM to take over parts of your business, the more token is going to consume, and the more cost is going to incur. So that's fundamentally changes. It makes it lowers the barrier to entry, but then also at the same time makes scaling much more expensive for larger companies. And then, so that's essentially the lesson one, session one, and then giving you a history of kind of like where AI came from, what is really different about this time when why people are going crazy over this new era of AI and why it's going to change the world. And then in our next session, we'll really talk about kind of uh, why in this era of AI, it can do things like agentic workflows. Why it can, why is it that you can tell it to, hey, I want you to do A, do this, B, do this, C, do this, D, do this, and you just give it a set of instructions, and the AI is able to follow that instruction very clearly, and then work with you and then report back to you on what happened and how that's really changing the adoption within companies. And why we're talking about this, like in the future, is everyone gonna be working with an agent, working for an agent, or is agent going to change everything? And that's really a big part of this agentic slash AI revolution we're seeing. So Thank you for your time. If you have any questions, please contact me. And then, yeah, I hope you enjoyed our first lesson.